Okay, you're live.
Okay. Okay. Thank you. Let me just share my screen. Okay. Share. Can you guys see my screen?
Yeah, it's visible.
Yes,
Okay.
yes.
Just that. Okay. I need to. To remove this. Okay. Okay. So hello everyone. Welcome to my talk, testing in Flutter, basically in the real world. So as I've introduced already, but I will introduce it again. My name is Burhanuddin Rashid, and I'm a software engineer at Sahaj, currently working in Sahaj, and I'm also a Google developer expert in Flutter and Dart. So I think most of them you are familiar with Flutter, for so then it will be easy to me to get started with testing in Flutter. But if you are completely new to the Flutter, then some you might find some concept not relating to it, because uh, this is something about having the app already and you are writing test for that. And I'll also some talk about some testing and how to do that and all. So uh, so what we are going to learn today, we are going to learn first of all why we need testing. We need to understand the necessity of that. If we don't, then there is no point of doing this whole talk. And then I will discuss how can we get started with zero test. Basically, you don't have any test and you wanted to write the test. And then we'll look into type of testing with Flutter with some example code. And then we'll have some quick intro on some CI/CD solution which are currently available. So the first question is why we need testing. We need testing because of this. Like whenever we release an app, we don't want to be in this situation because we are just praying to God that everything works fine and doesn't break. So basically, there are two type of people like this. One, the left side of me is me, and the right of side is my colleague who is just enjoying what we are doing. So we don't want to be fearful when we do every release. We want to be much more confident that in that. So in that scenario, testing help us to reduce that. And how does it help in the testing? So basically, testing provide a better user experience because you have a frictionless releases. You catch bugs very early on before the product or whatever app is shipped to your customer, so they don't feel anything crashes or unnecessary user behavior changes or something which was working previously and not now working as expected. So basically, it's provide a good user experience, and a good user experience is a good for our app. And the second thing is refactoring. Majority of the time we write tests because we can refactor very confidently. So as Martin Fowler said, that if we want to refactor any code, the essential thing is to have a solid test in first place. So in order to refactor, you need to have test, because refactor means that you are just changing the existing design without altering the behavior. So you want to preserve that behavior. And how do you know that you are preserving that behavior? By having test. So if you have a test, whenever you are refactoring code, if something breaks, your test will be catch that, and you will able to know, okay, I'm making that mistake, I need to change the code again. So this having test give you much more confidence in refactoring the code. And if you don't have a test in place, then when you refactor the code, after refactoring, you have to manually check all those steps. Like if you are changing a button text, you need to run the app and see the text and click on it and see whether it's working fine or not, or some other behavior is unexpected behavior is not happening and all that. So test save this all manual testing time when do we refactor. uh, and the third part is basically generating more money, more revenue. It sounds little counterintuitive because if you write test, it will take more time. And in our IT industry, software development cycle or something, so software industry basically, if you are taking more time, then it costing you more money. But if you tie back this to the point number one, which is a better user experience, it will help you. It will help a better user experience, then user will be happy, they will share their app with friends and all, and they will be, stay on your app much more time, which eventually will lead to you more revenue. But testing in real world is not like that. I mean, what I have described, because when people do testing, they do always on production. So this is one of my story where I was working with my colleague and our client came with some change. So instead of creating a normal process like creating a Jira ticket what we want to change, and then create a PR code review and write a test for it, what my friend did is he went remotely, log into that production server, went there, change the code there, and just hit Control S, Control Save, and restart the server. And that's it. That's how people do testing in real world. So there are many factors why people do this kind of stuff. The basically the main reason is we are living in a startup kind of world where we want to build everything fast. We want to validate our idea very quickly. We want to put our product into market as soon as possible. And Flutter is very much known for its development speed. And if you have some idea like MVP product or some kind of thing, then it's validate your idea very quickly whether it's going to work in a market or not without investing much of your money into it. So because of that, we don't have that much time to write tests because we are want to ship it as much as early as possible. So we don't get to time to write the test. And most of the time we work on an existing code base, that is legacy code base, which was written by someone else, and they were also going through the same process, like they were not having time and all that, so they didn't write test. And now we have that code and we need to write test for that. And most of my consulting experience where I've been into few meetings where why we need to choose Flutter and just what we have done so far and just doing a code review and all that stuff. I found that most of the company start with a good architecture structure, separating separation of concern and defining a layer and communicating between those layer by interfaces and all that. But most of the time I see that they don't have a test, and if they have tests that are not a good amount of tests, but mostly I don't see them writing a test when they are initially building that product. So now the question is, then how do we get started with zero tests? If we don't have any tests in first place, just the app, how do we get started? So when you get started, when you see your legacy code base which was written by someone else, this would be the reaction, and you might be thinking what this meme have to do with this code base, and it doesn't make any sense. Actually this meme itself doesn't make any sense because it is from the movie, which doesn't make any sense, so I just put it here. Now coming back to question, how do we get started with zero test? First we need to understand what kind of testing we is available right now. Based on their pros and cons, we can choose what to get started with. So there are a lot of jargon words about testing. You will hear about smoke testing, sanity testing, interface testing, integration, beta, regression, volume, capability. There are a lot of kind of testing. We are not going to focus on all those kind of testing. We are going to basically focus on three testing, which are provided in Flutter. So one is unit testing, the other one is widget testing, and the third one is integration test. So just to summarize, what is unit test is basically testing your function, method, or a class. Or you say if you are creating a validation form and you have a function which validate that form, that function is a good candidate for a unit test. If you are calling an API and getting a JSON response and you are transforming that JSON response into your UI model or something like that, then that function of transformation is a good candidate for unit test. Now, coming back to the widget test, widget test is nothing but what you expect to see on the UI. And whenever you interact with that widget, what should have happened? So that is basically widget test is. It's if you are coming from a React background, then you might, this widget is equivalent to a component, just a small component which you test. And integration test is nothing but end-to-end test. Sometimes people interchange this word. So in here, when we are talking about integration test, it means end-to-end test, which mimic the real user on a emulator or a real device. When we click on the button, it navigate to different screen and all that. basically a real user interacting with the app. Now we have seen this standard triangle, basically, which describe how your unit test should be and the number of unit tests you should have. So this, it prefer that you should have less number of integration tests and highest number of unit tests as much as possible. The reason behind that is because integration are slower and it's more expensive, and unit tests are more faster and cheaper to run. We'll talk about this in more as we go through each type of testing. So when you talk about the standard approach, this works fine when you have a good test in place and if you are following TDD. So TDD is nothing but test-driven development, where you write tests before the code. So this works very fine in that scenario. But if you are working on a legacy code base, then writing a lot number of unit tests is very hard, because your code is not structured in a way that you can test individually each component, and also it consume more time to write more number of unit tests. And let's say if you are writing a unit test of adding a calculator app, where you are adding a number a plus b and you are just verifying that as a unit test, it won't provide that much confidence, because you are not actually able to see that on a user real interface whether it's working on clicking on a 1 plus 2 and it's showing the proper result. So in terms of legacy code base, this pyramid might not work as you expect. So what is the solution? So the solution is something like this. I hope you get it what I'm trying to say. Basically, you flip the triangle on a legacy code base. So when you are like working with a legacy code base, when you don't have a test, you try to write much more number of integration tests and less number of unit tests. The reason behind that is the integration tests provide higher confidence, because you are testing to a real user. So when you are testing against a real user, then you don't have to structure the things, change a lot of things to make a unit test work. So in that sense, if you are already a code, then if you are writing more integration tests, then it will be more beneficial for you, so that if you have a good amount of integration tests first, then you can refactor it to something like going down to the unit test, like write 10 integration tests first, and then after having a good confidence in that, just refactor your code and just try to increase the number of unit tests, and then try to make less number of integration tests. So let's start with the integration test. The reason why I'm starting with the integration test, because in the real world, when you are going to write a test, if you don't have any test in place, then this would be the approach which I have tried and it worked for me. So I'm starting with that. So why integration test versus unit test? This is the door where each component, each unit is working fine, but integration is not working. Uh, this is my favorite one, where I don't need to explain that. It is self-explanatory what's happening. So in order to understand the testing, how we are going to write a code, we need to understand what we are testing. So basically, we are testing an app called What to Do. Just So we are testing an app called What to Do. So this is, as its name suggests, a to-do app, which is basically adding your task to the project, uh, creating different kind of project and assigning tasks to it, and then sorting and filtering those tasks based on a project, based on a label. And then we have some user interaction, like if you just swipe it from left to right, it will mark as a complete, and if you swipe left to right, then it will delete the task. So this is what the app does. I started I create this app 2 years back, in just to understand and learn Flutter. So this is how I get started in the Flutter in the first place. So when I started out, I just wrote the code in the terms of learning, and then I structured it into a block pattern. And then after some months, I thought that at least I should give a uh, try to write a test. And this is where the whole journey came out, and this talk. So in integration test, we are going to use Flutter driver, which will run our app on a real device, and it will run on a separate process. So The test which we are running, it's run on a different process, and the interaction which we are having, it's running on a different process. So basically a different thread. Why that is important, I'll explain that in the code samples. And it's a similar tool like, Selenium for web, Protector for Angular, Espresso for Android, and Early Ray for iOS. Now, enough of blah blah blah. I will just get into the code. So first, you need to add a dependency in order to start a Flutter driver test. So this is how you add a dependency in your pub/spec YAML file, and then you'll create a folder test underscore driver where you will create your test file. So first you will create a dart file, home page, you can name it anything, and then you'll create this function main, and you will enable the Flutter driver extension. This tells the APK that this APK is running based on integration test, and do the interaction based on the test written it. And then we'll call app.main. So app.main is nothing but our entry point, our Flutter app, where the app starts. So this is our entry point. We are defining that, okay, start my app from main. So this is how we write the homepage, the entry point of a class. And then we create another file with the same name, appending underscore test.dart at the end. Now, appending underscore test in the dart in the end is important because it will map that file to the entry point you have defined. If you don't write underscore test, then when you run the Flutter command to run a test, it won't recognize that file, and your test won't run. So we'll write our test in this void main function where we have homepage underscore test.dart. Now, this is our main function where the test starts. And then first we'll create a group. So basically this will logically group your test. You can create multiple groups also. Like for this group, I'm creating homepage. So whatever test I'm writing for homepage will be going into this group. And then you basically set up all and tear down, which is connecting your Flutter driver when we are setting the test and tearing down. So set up all and tear down will run once per group, but if you want to run every test, then you just use the setup and tear down and just remove the all from there. Now, the first thing which come into your mind, that what test we need to write. So first we need to just start from a basics test. I mean, like when I'm starting my app, I see this screen where I see a title on the top, today, which is the by default filter, and I see a no task added because there is no task added on the screen. So we can write a simple test that whenever I start my app, just test the title and this no task added. So what I'll do is I'll write a test for it. I'll create a test class, and I'm giving async here because I'm using driver, which is asynchronously, get the all the text and mesh in the test. So this is the find by value key, which is the API in the Flutter test, and I'm just using this home title key. So initially, when I was not having any test, this key was not defined. So as I was going through the test, I was adding those keys. So this is basically my widget, today widget, where I'm just initialing setting the title based on the stream, and then I initialize a key value key here, and I initialize that key as a string from a constant file, so that it will be will be consistent throughout the app, and it will be easy to maintain. And then I use the same key to find that home title, and using the driver API, I'm getting that text and matching it that it should be today. And then the same thing I'm doing for the message in center. So there is a key message in center which takes this widget, and just I am matching with no task added. So when I run this test, it passes because that's what it's expected to be. Now, moving to some more complicated test where I want to filter the task based on whatever I have selected. So let's say I'm selecting today, or I'm selecting next week, or I'm selecting any project or anything. Based on that, my task should be filtered. So I'm just writing a test here, show today's task, and I will write this test. I'll explain what actually it does. The first thing is future dot delay. I'm just giving a delay. This is just a hack to initialize my database here. And then I'm finding that drawer key on the top. If you see from today, there is a key side drawer where I'm finding that widget key from the value key and just tapping on it, which will open the side drawer. And then I'm clicking on it. I'm finding that today widget and just I'm clicking on it. So when I click on it, it will just verify today, and then I will find those value task title one, task project name one, and just matching whether it should be task one in box. Now you might be thinking, what kind of key is this task title underscore one? So basically, I have a row widget, which is which where I'm show the title, and I'm adding that value key dynamically because since it's a list, I'm adding a key dynamically which is task underscore title underscore task ID. So whatever ID that task holds, I can get that key. So this is how I'm adding in, so that in a list you can match a specific element to it. Now, when I get the task one, same with the task project name, and I'm matching with task one and inbox. But as you see, it will fail because there are no tasks added. We are just launching the app and just trying to match the task. The reason behind is because we have not added any task. The one way would be do is to write a click event on an ad and then enter the text and add the task, and that would be very tedious and the code will be very long. Since just we need to test a filter, this the code is look very long, and then that test code will be much bigger. So one way of you can think is, okay, then I'll get my app database class and add my task directly here. But if you try to do this, you will get an error like you cannot find Dart UI. The problem here is, which I explained earlier, that the test code and the actual code run on a separate process. So when you try to access this add task, which is basically residing in a Flutter framework, Flutter, we are accessing Flutter framework code because you are accessing the DB instance, it will fail. So then how do we access anything related to the Flutter widget or Flutter UI framework related? So basically, the first thing you need to do is pre-populate the database, and you cannot access the database directly here. The one thing the thing you can do is you need to set some communication between your test code and the Flutter UI framework code. So how do you do that? We have this class homepage where we defined, if you remember, we have defined our entry point dot main. So here we can access any Flutter framework or UI related code. Because we are calling app.main, we are defining the starting point of it. So what we do here is we create a function called data handler where we get an input message, and then based on that key, we perform some action here on the homepage.dart where we can access the Flutter framework code. So I'm using seed data in DB and clean DB. So this is nothing but just a function which add your dummy data into the database and just cleaning up the database. Now we are passing that function into data handler, enable Flutter private extension method, so that you can access those handler into the test code, and then you can communicate between that. Now we have passed the extension here, but we have passed the handler here, but how do we get control of that in the test? So as you remember, this is our test class, and I have explained you the setup and tear down. So in that, you access through a driver API called request data. So whenever you request a data, it will use that callback method on a Flutter driver extension, which we have defined. So when I'm setting up the Flutter driver, I'm adding the data, and when I'm just tearing it down, I'm requesting data, clean data. For simplicity's sake, I'm doing this to be on a setup all and tear down all. You can change this based on your need. Like you can just do in the start of your individual test and at the end of the individual test. It's completely depend on your scenario. So now when we test this, it will pass because now we are adding the database before running the test and cleaning it after that. So this will pass. Now there might be a scenario like you want to test just one screen. So in earlier screen earlier test, we saw that you are just starting the app from the beginning. But let's say you have an individual screen like this about screen, which has nothing to do with the API call and all that stuff. That is just a static screen there. So how do we test that? I don't want to load whole my app or mocking the database and just adding the dummy data there just to start my app. So you can also do that. So we see that our enable Flutter extension method, we are defining app.main. So this is where our app starts. So you can change that entry point to anything like material app about a screen. So you want to run your app with the only just about screen. We are wrapping that into material app because about screen required some ancestor as a material app. So you can start any screen from here, and then on the test file of it, you can just get those keys and just match to what you are expecting about a reporting issue. And then your test will pass. Now, getting back what we have gone so far, in the Flutter driver, this provide a very high confidence, because the reason is like, if I'm just launching my screen and I'm able to test today and no task added, there are a lot of cases I'm already covering without writing any much of unit test or widget test. Because of that, once I have that test in place, I can refactor all those scenario very easily. Okay, just what happened. Okay, and it's very close to a real user. Like we are just mimicking what the actual user will do. It's catch major bugs early on, because like I said, if things are working in a unit manner, it will catch major of the bug which are of the integration test, what the end user actually sees. And it easy to write after the fact. The after of the fact is that you have already a code base and you don't have any test, then integration tests are something which is very easy to start with, and it's provide more value. But the disadvantage of this is its execution speed is very slow. I'm just showing a code here and just showing that it would pass. I have done a demo of the same code base in my previous talk on the mobile Daisy, where I was just doing this demo live. So while doing that live demo, you can see that when I want to run a test, how much time it takes. It's just build the APK, install the previous APK, install it, and run the test. So it takes a lot of time to just run a single test. So because it has very more of dependency, you need to have an emulator, you need to have SDK, Flutter SDK, Android SDK, and all that stuff. Because of that, the maintenance costs become very high. Since if your integration, if you just have an integration test and it's grow in a massive amount, then your feedback loop will be very slow, and whenever you want to test something, it will consume more time, and some more flackiness and all that stuff. So basically the maintenance cost would be uh, here very high. So the key things you need to remember from here is that you need to append underscore task dot underscore test dot dart. Don't forget to do that. I have spent hours and hours just figuring out why my test was not running, and I found because of this. And you need to understand you cannot access the Flutter UI framework related code into the driver test because of the run on a different process. And you can access the Flutter UI framework into the homepage.dart, which is where you define your entry point, where basically you are enabling your Flutter extension. You can use data handler for the communication. And if you are running slow test in the emulator, then you can just try running on a desktop app, which might take much more faster approach to do that. Now let's go to our second part, widget testing. Uh, Widget testing is just basically a single testing a single widget. It's like of a UI testing, but not actually running on a real device. It's just a small component which we are testing in isolation. It's verify your look and feel of widget, how the element are aligned, what kind of color is being visible, what text has been changed, and all that. It's also verify the updates and whatever user interaction you are doing with that specific widget. In order to understand the how we write the widget test, we need to understand how the app is structured. So basically, the what to do app is structured on a block pattern, which is nothing but a business logic component, where you have a component where all the business logic is reside. You don't have any UI framework related code. It's just a pure Dart based thing, and it exposes the stream, and you listen to those streams. Uh, so this is how the what to do app structure looks like, where I have app database, which is responsible for creating the instance of the database, upgrading and migration and all that, and just providing it instead of initializing the database, and providing that instance through different classes, which are label DB, project DB, and task DB. So these are basically table based classes which handle all the table specific query into that class, and then I inject those classes into the block. So block can be anything. It can be based on table. So here it's a task block, project block, labor block. It can be based on screen, where let's say example, I have a add task block which has been created based on that screen, and it required all of those three DBs. So we inject all those three into add task block. There is also a home block which doesn't depend on anything. It's just word independently. You can think of that of as an event bus kind of thing, which is defined on top of your hierarchy, and anyone can access that to communicate with each other. So this is the structure of the app. Now we'll see the block widget relationship between those structures. So basically, each screen will have a block for it, task block, home block, you can see. And then for the adding project and add label, they have each block for them. Now here the home block, as I said, it's defined on the top, and it can be accessed by its children. So here the side drawer can access the home block, just passed in event that you want to filter based on date, based on a project or something like that. And then when you create a project, a page, or a label a page, here we create a project label and the label block, and we pass that into add project and add label. So this is how basic the relationship is between the block and widget. Now let's see some code. I don't know why my mouse getting here. Okay. So here, instead of test driver, you create a folder called test, and that you create a file. The same rule apply here. You need to have underscore test.dart at the end in order to catch up the command as it's working as a test. Then what we are going to test is we have this screen, and we want to test this specific widget, which is basically a project row, where each row have the name, color assigned to it, and there's a space in the beginning. So we'll just test this widget, not everything. So in order to write a widget test, you use a class called test widget function, which takes two parameters, the name of the test, and it will give back you a tester object, which is nothing but a helper class to test your widget. Now what we are going to do is we are going to use a method called pump widget, which basically inject your widget you want to test into the tree, and so that you can run test against that. So here we are creating a project row and passing a test project, which is just a dummy class I have created. And then you are finding a text for that name, and just using find once widget. So find one widget is nothing but verifying that this name has been found once in the tree hierarchy. If you want to have n number of time, you just use find n widget, and there's also find nothing. So based on your case, you can use that. Now, if I run this test, it will fail. The reason might be we get because the block was called null. Now, why it was called null? We'll see that. So we see when we see a project row, it is a stateless widget and it's taking the project instance. We see that we are accessing a home block here, which is coming from a block provider dot of context. So basically this is nothing but finding a block, home block, into its parent widget. Since we are just injecting, we are creating a project row, it doesn't have any parent, it failed to find this home block, and whatever operation we are doing, this home block is going to null, and hence it's crashing. So how do we solve this problem? One way to do that is we just wrap into a block provider which provides the widget, the home block. So here we are creating a block provider where we are creating home block and passing that home block so that project row can access that home block. Again, when we run this test, we'll see an error because it will say that list widget require a material widget ancestor. So since we are using a project row, I am using a list style, which requires an ancestor as a material widget because it's getting theme from that material widget. And we don't have that material widget here. So another thing, the same thing we can do, we can wrap this block provide into material app. Now material app, now since this operation is going, this things is going to be required by pretty much all the widget because we have this material app. So instead of doing this in all the places, I created a handy extension function wrap scaffold with the block. You just provide that block and it will wrap that widget into that whole app. So you can see the extension here. So this nothing but takes a block as a T type of T, and then it's wrapped into material scaffold block provider, and then whatever the extension has been, run into. So it will provide that as a child. So when we run the test, it will pass. Now we are going to test how that dot will look like. So I am using a tester object and I am using a find it widget by key. So this is nothing but an extension which I have created. And you are seeing that there is a dot underscore person underscore one. So what is that? So basically that is nothing but the key which I have defined dynamically in order to get specific project. So if you see the key, there's a container I have provided a height, and then there's a circle. And that value key, you can see I'm using dot underscore project name underscore project ID. And also I have created this extension function to find a specific type of a widget in that tree. So I have used that find by widget by key, and I'm finding a circle avatar, and I'm matching those color value with the test project one, and it will pass as well. Now we are just matching the space. So I'm just getting another container which has defined space underscore person underscore one, and then I'll match with the whatever height I have defined it. And this whole thing will test the only one single widget for me. And yeah, I mean, it will pass. If you are not able to understand any of this code or you are finding something, missing it out, this app is open source what to do, and all the test cases are available there. So I'll share the link at the end. You can go through that, and there are way more complex tests also, like just gesture navigation, swiping it, scrolling and all that, navigating to multiple screen and all. So you can find those scenarios there, and it might be helpful in your project. Now we want to test the user interaction. So basically on the specific widget. So when we click on that project row, we filter the task bed based on that project and update the title on the top, which is here a personal. So we need, how do we test that? I'll just write the whole test and I'll explain you how it does. So first I'm creating a home block here, and then I'm passing that home block using that extension. And then instead of testing whole other UI, I'm just testing the block where this event has been passed. So I'm just testing if on the user interaction, I am passing the event properly or not. So I'm just here listening to home.title, and then I'm just passing a project name. So it should listen to, when I click on any project row, it should listen to that name. And also it should filter by, it should get this object filter by project with that specific ID. And then I'll find that row which have tile underscore person underscore one, and I'll just tap on it. So when I tap on it, it will embed that stream, and the home block on the top will listen to it, and it will just pass. Now you might asking why I'm writing a expect before the tap. The reason behind is that it's listening to the stream, and it will listen to the stream when whole test suite get completed. So if, let's say if I write a expected home block dot title after the tab, then what would happen is that when I tap it, it will pass the event, but at that time there won't be any block to listen to it. I mean, won't be any expect to listen to it. So when I run that test, then it will fail, saying that we were not able to find any name with that event. So that is why it's had been defined before that. It will wait for all the tests to be, I mean, all the code in that line to be completed, and then it will check whether the event has been passed or not. And then it will update the title and it will pass the test. Now, the key thing here, remember, is that await.tester.pump. This is not part of this test. I'm just want to explain it here that currently I'm just updating a stream, but there might be a scenario that on a click of an event in a widget, you are just changing the text within itself, like edit text, something like that. You are editing some text in that and it's changing within that widget. In that scenario, you need to, if you are running that app in a real application, it will refresh the widget automatically, because that's what the build method does. It refresh it whenever something gets changed. But in test, it doesn't happen. You have to manually tell the test that now it's the time to refresh yourself. So you use tester.pump, which will, after any interaction, will refresh your widget and you will see the expected behavior. uh, it might happen that you write the test and it's not working as expected most of the time because you are not refreshing at the right moment. Now we are doing widget testing using widget tester object. The advantage of it's very fast, like almost unit test. It doesn't require any real devices, and it's focused on a very small component look and feel. So that is what the widget test gives us. But the disadvantage is the parent widget dependency. As we see that in order to test a project row, I need to wrap it into a block provider and then material app. So let's say if you are testing a widget which is 10 level deep into your hierarchy, then you need to wrap into some widget and widget until unless you get that dependency. Let's say if you want to test something which is on a, you have a dependency graph from 1 to 10, you are 10 level deep and you need something at the 7th level, then you need to wrap into those three parents. Okay. You need to use more fake or mock classes here, and you don't see actual real design. What is actually happening, you don't see that. You can fix that by using a golden test. That is nothing but taking a screenshot of whatever the test has been run and just matching with the so it will save that screenshot, and whenever you run the test again, it will match with the previous screenshot. So basically it matching image to image. So in that you can see the how the UI looks like. Now, the key thing, remember, is parent widget, wrap what is required. Don't try to wrap everything in order to make it work. Just see what is required and just wrap into that specific parent. Try to avoid unfinished streams. Like in many scenario, you will be exposing a stream which is just listening and waiting to be get completed. But if you are running that in test, then it will stuck forever, because the stream would never finish and the test will wait to get that finish. Use find widget API, like find one widget, find n widget, and find nothing to match your UIs. And fake versus mock, you need to remember where you want to use fake and where you want to mock. Now, let's getting into the last part, which is the unit testing, third part basically. It's just pure test your business and app logic. It doesn't test anything related to your Flutter UI framework code. It's basically pure Dart based test. In our case, which is home block, sorry, the blocks, whatever. It's verify the function, method, and classes, and it does not test actual user interface. It just purely tests your business logic. Now, time
Burhanuddin,
to see.
yeah,
Yeah.
sorry for. So there's a question on chat, and
Hmm.
Sam says, "Hi, bro. Do you have any examples for GetX?"
Sorry, I haven't got time to explore that.
Yeah.
So I'm not sure. I don't have any example for that right now.
Okay, cool. So let's continue, I guess.
Is there any more question or?
Yeah. Do you guys want to? So actually, I wanted to ask one. So
Yeah.
you mentioned that these tests run on two different processes, right?
Hmm.
Basically on two different threads. So is
Hmm.
there, any good reason behind it? Like why did Flutter do it that way?
Uh, to be honest, I'm not sure, because eventually the interaction which happens, like the user interactions, they want to do on a different thread than the actual running code. I don't have a strong reason for doing that, but I see the similar thing in Android also. When you are running an espresso test, and if you're trying to do something right there, if you want to test a widget there, it's
Hmm.
also phased because it's running on a different thread. So I see the similar pattern on most of the test uh, test test suits, but they provide an API to access that code easily. But currently in Flutter, it's not there. Recently, they have introduced integration test, which works like a widget test. Uh, I, I, I mean, I didn't put that in this slide because I haven't explored it yet. So I think the next thing would be to explore that, and how to solve this issue, like running on the different processes and interacting, setting up a handler and communicating with each other.
Hmm.
So
Okay.
I
Okay.
I didn't answer your question, but yeah, I mean,
No, but
I'm not sure.
it helps. I can look it up. Hmm. Thanks, man.
Okay. Uh, okay. Okay. So unit testing similar with the how we did the widget testing, but here we need to add a dependency test.any, and since we are not going to use directly Flutter framework code or UI code, we are using Mockito here to mock that stuff out. So this is just an example where we have a home block, which is nothing but an exposing a stream called title, and there's a method which is updating that stream. And similar, there is a filter stream, and there is a method which is updating that stream. So we kind of basically do a unit test for this. So this is how the unit test look like, where we are creating a block, and we are expecting the filter by this order, by today, by project, by label, and by next week. And then we are we are calling that by method apply filter and passing those filter by it, so that it just match in the order which we have called this method. Now, you need to remember one thing, that if you are emitting an order, if you are using a primitive type like integer or a string, that would definitely pass, because it's been pre-built, it's a primitive type. But if you are using an object, like here I'm using a filter by today object, if you try to run this directly, filter by today, then it will fail, because filter by today is a different instance, and filter by today which we are checking in the emit in order, it's a different instance, so it will eventually fail. We need to set some equality in order to match the same thing, basically overriding the equal to or hash code in the Java world where we do. So here in the filter class, I'm just overriding an operator for the equal to, and I'm just matching it, that if every field, every property is the same, then the object is same. So in that scenario, my test would pass. So this would pass. Now let's look into little more complicated example, where I have a label block, and this label block is exposing a list of labels. So when I'm creating this label block, it's calling a method load label, which is getting a label from a DB and just updating into the string. So here since we don't have any access to DB, which is the part of a framework, Flutter framework, we are going to use fake here. So I'm creating a class fake label DB, and and since you see that I'm just injecting that class into label block, I can inject that same fake DB here instead of a real DB. Now, how I create this fake label DB? I just create a class and extend to the fake. The fake is nothing but a class which is provided by a Mockito library, and it's implement the label DB which we want to fake it. And then we override this method called get label, and then we just add the test label which are not there in the list and return as a future value. So basically this get label is called when the load label method will call. Basically it will fake that value, and then when we run the test, it will pass because we are passing the fake value from the DB and just emitting in order, and it will match those labels. Now, to summarize, I mean, the advantage of unit testing is blazingly fast, like the flash fast. It just runs instantly. It has very less dependency on Flutter UI and framework code, and the maintenance cost is very low because it's run very fast, and we need to doesn't need to maintain any most of the like the integration test. It doesn't have that much of dependencies. It's a very good candidate for TDD, like test driven development, and it provide a very fast feedback. If you are trying to do some calculation and logic, then you are just getting the feedback instantly, instead of running through whole integration and widget process. The disadvantage is when it's come to a legacy code, you'll have very less confidence, because as I said, if you are testing a plus b, that's fine, but it's you don't know whether it will be visible to a UI properly or not in terms of legacy code base. So it become very tricky in terms of legacy code base, because your app is not structured in a way to do that, and it's very less to a closer to a real user in that sense. And definitely the whole is greater than sum of its part. Basically, if small component you are able to test that small component, but they are not working it together, then it won't provide that much benefit. And after the fact, unit tests consume more time. Like if you already have an app, then to write a test for a small part, it takes much of time. I have seen a unit test where it was testing just one method, and it was just testing one method, and there were 4 mock classes there. So because of the app was not structured in a way, and we are trying to write a first test in that app, and we are trying to write unit test as a first test for that. Now talking about some CI/CD solution. So this won't be any detailed intro, just a quick intro to get you started. So there are 2 options available currently, which I have tried, which is Code Magic and GitHub Action. So Code Magic basically built for mobile apps to test. So the all the pain which we have, like starting up the emulator of different version, waiting for boot up, and then running the test, the flakiness, shutting down the emulator. This whole thing is covered by Code Magic out of the box. You just need to say what you want to test and where you want to test. It will do for you. So you would need to first sign up with your GitHub account, and then you can choose what kind of workflow you want to run. So you can run a Flutter app, you can just run specific widget test, you can also run your Dart packages and library which you are building. It also tests Android app, iOS app, and React Native app also as well. So this is how the page look like, where you see all the build trigger, whatever environment variable you have set up, how much time your workflow takes, what is the status, and all that. And also, as you can see that you are seeing the preparing, build, fetching, app source, all those steps are defined out of the box. Like building an artifact for Android and iOS, it does out of the box. You don't have to do anything specific for that. It knows how to build that, and it provide all the artifacts for you. This, I mean, will help you more if you are targeting more platform, like you are targeting window, you targeting Mac and everything. It will automatically be all those artifacts for you. You can select what kind of platform you want to run. Here I'm selecting Android and iOS, so it's generating artifact for that. If you select more, it will do that for you. And then you can also define the post test script and pre-built test script if you want to run something custom before the test run or after the test run. Then you can do different kind of enable testing, like Dart analyzer, Flutter analyzer, and where do you want to run the test. You want to run on iOS emulator, Android emulator, or you can also use AWS device farm to run the test. And then you define the Flutter driver command, that which test you want to run. Then it's come the publishing phase, where you define all the keys for Android, iOS, and then you define an email where you want to notify it. You define the Slack ID key to be notified on Slack, and all the other options available for that. Now, talking about GitHub Action, they recently, I think last year, they announced GitHub Action. So you can pretty much start with GitHub Action by creating a folder .github_workflow, and where you define a main.yaml file, where it will define all the configuration to run your workflow. So this is how the YAML file looks like. On push, where you define the event, whether you want to run this workflow on the push, like on every commit, or you want to generate when a PR is created or something else. You can define that event, you name that. So yeah, that you can find that into logs. And then in the job, you defined where you want to run this test on. So here it's Ubuntu latest. and then you define a step. So in this step, we are checking out the repo, setting up the Java version, which is 12.x here. And then we are using an action, community build action called Flutter action, which will basically load the Flutter framework into that repo. And we are just defining the version, which version we want to load. And then we'll run some Flutter command, which is flutter.pubget test and then build APK. So after building the APK, we use a release action, build action called release action, where it gets the artifact, whatever the APK you have built, and based on the token, it will give you the release APK of it. So this is how the dashboard look, where you see all the steps and how much time it took to do that step. Now I think after this 1 hour talk, now we know how to write tests. So whenever we deploy any test, our reaction would be something like this. We will be more happy and more confident while deploying any releases when we have tests in place. So to summarize, we understand why we need testing to have a better user experience, have a refactoring confidently, and it will eventually lead to more revenue. Then how can we start with zero test? We see in the standard approach, we need to have more unit tests, but in legacy, we are trying to have more integration so that, we have a good confidence in initial phase, and then you can refactor it and move that into more unit test, and then reduce the number of integration tests. Then type of testing with some code, like integration testing we did with the Flutter driver, and we see the limitation and advantages of it. Then we use widget tester to test a single component, and then we unit test it, which is basically our block test, whatever block we have created, we did that. And we see some quick intro into the CI/CD solution, like Code Magic and GitHub Action. So these are the resources, the blogs and video. You can check it out to learn more. I have learned many things from these blogs and these videos. So yeah, thank you. If you have any question, I can take the question now. Uh, I'll stop
So
sharing my.
there was one question from Bhavya. He asked that is it possible to build iOS app from GitHub Action?
There are some Git actions are there. I mean, I have not personally built it, so I am not sure. But I think the community is building so many action in that, so I think you can pretty much do that. I mean, if Code Magic is doing it, I mean, there might be a way to doing a GitHub action. The thing is, you need to search for a right action for that. Okay, is anything? Okay, so does anyone have any more questions? Anything you didn't understand? I mean, the thing which was hard to understand.
No, I think it was well presented with the animations and all. I think it was quite interesting for me at least.
Mm, thank you. So what not to cover in test? The answer is don't try to test the implementation details. Basically, like try to test the behavior. Like if you are having a Pojo class, like don't test getter and setter method for that. What that class has been doing, what behavior it's providing, it's better to test that. Because if you test the implementation detail, the problem will be that implementation will change very quickly. Instead of if you just use the expected behavior, then it would work fine. Like in the test, in the integration test, we test that home title should be visible and the task added should be visible. So if anything underlying that is changed, then it won't matter, because the test we are testing is it show the specific behavior it's supposed to. Like if we try to test that, okay, I'm getting a list in integration test, I'm manipulating that list, how that list being used throughout different component, then when the implementation of that list change, then you also need to change your integration test and all that. So try to, I mean, I'm just saying it, but it's not that easy. It's come from practice, basically. The more practice you do, you will know that what not to test. I have also tested the getter and setter method itself. So I didn't, and then later I see that it doesn't add that much value. It's just like basically, 100% code coverage kind of a thing. You just want to coverage everything. But yeah, try to test the behaviors, not the implementation details. Uh, Sorry, but I haven't explored that part in Flutter, where how to do a code coverage report and all. So I don't have any recommendation, but I'll definitely get back to you if I find anything. Yeah, uh, sure. Thank you.
All right. Thanks. I'll end the video recording.